Hello, I'm here to make another video on segmented turning. A friend of mine, Bob Nolan, gave me a piece of tulip wood and 2 sticks of wenge. Plenty of wood to make a small segmented piece. So first thing I did was to take this piece of tulip, slice it into 4 slices. Gives me about 4.4 inches each, and it's 6 inches by about 7.5. So I have no idea where I'm going with this project, other than the fact that I have the wood, and my goal now is to really find a plan that will give me a hollow vessel out of segment turning. What I want is to maximize the size of the vessel without running out of wood. I want to incorporate this wenge, which I have, which is nice wood. Perhaps a small insert in the bottom, perhaps using it as a filler between the segments. We'll have to see where we go. So my plan is to go into the computer, take a look at different shapes, and then make different sizes of those shapes until I can find one that incorporates the wood that I have here. So let's see where we go. So here I am in the office at my computer, and I've opened up Woodturner Pro's 3D Pro, which is a design shape program. And I selected a shape I've used many times before, a southwestern pottery form. I like that. So I'm going to import it into Woodturner Pro, where I can then create a segmented vessel from that. So from that, I can then determine the exact size the vessel needs to be, and whether or not it'll fit the amount of wood I have. So I've created the program, generated the shape, and it creates for me a cut list, which gives me the information on that program. However, that's not okay for me. I want to mix segments and spacers. So I went and exported that into Excel and created my own spreadsheet. This spreadsheet will allow me to be able to look at the segment edge length I need and the spacer edge length that I need for that. And those are going to be measured out to 1/1000th of an inch. Now I can't actually accomplish that, but I'll do my darndest in trying to get as close as possible. So here's how I cut and build one of the rings. So what I'm going to do is I'm going to set the segment edge length for the segment I'm getting ready to cut here between the saw blade and the stop. I'm marking a piece of wood with a line on its top and on its front face. This will allow me to keep it oriented properly on the wedgie sled that I've created there, the white plastic device. This will allow me to cut 12 segments very accurately. So what I'm going to do is to keep one face of the board up, one face forward, trim the end, and without turning the wood, I'm pushing it against the stop, establishing up the segment edge length that way. Then back to the second fence to cut the second, and then back to the first to cut the third, and so on. So we'll get through this much faster than I can actually do it. This is the best I can come up with. 12 segments, accurately cut. And once they're done, I'll save them into a small bowl, and with that I'm going to add the appropriate spacers for that particular ring, making sure we have all 12 there. So let's put this away, get rid of our segment stop, and I'm going to now cut spacers, and for that I built a special sled also. And this sled is designed to ride on both sides of the blade, hold the small piece of wood carefully centered, and I can then cut very, very small end grain segments. Well, not actually segments, spacers. So I'm going to set the saw blade like I did before between the edge of the saw blade and the stop. Each row is going to have a different segment edge length and a different spacer length. The sum of the two equals what was on the original spreadsheet from Woodturner Pro. May seem confusing, but as I go through this, you'll begin to see how these different dimensions play into the design that I chose. So I have the wood I'm going to use. It's a long grain, so I'm cutting across the grain so that the grain alignment will be the same as with the segments. Trim up a little bit to get started. And then I'm going to use a stick simply to hold that piece of wood down on both sides of the blade so it won't go flying out. Just to be sure, we'll check the length. Now that I'm satisfied, I'll go ahead and cut 12 spacers that will be used in conjunction with these segments. Again, fast cutting is a good thing, especially when you can do it with a video. Okay, we have 12 of them cut. We'll add them to the bowl with the segments. And now we have all the pieces necessary to complete this particular row. And you can see segment edge length, spacer length. The sum of the two are needed to create the ring I want. Now the tedious job comes. Each of these pieces needs to be individually sanded. All the edges cleaned, deburred. I don't want any fuzzy wood remnants to get into the joint and give us an open joint. So what we're going to do here is sand each individual one, and then I'm going to mix the segments and the spacers, keeping all the segments so that the face is up on all of them. The edge on the front side of that piece of wood is alternated inside and outside. These alternations help keep the wood perfectly aligned. If there's a small error in my table saw, that's accounted for by these adjustments in the settings. Well, here's the ring, all pieces in place, and we're ready then to glue this together and make this into a segmented ring. I'm going to use a standard hose clamp as a way of clamping them together and holding them tightly in position. I'm also using a new glue from Type Bond. It's called Fast Set, or Speed Set, I beg your pardon. And it is a takeoff of the original molding glue that they made. The difference between this and the regular glue, it sets very rapidly. It has very little drip. And is fairly thick. So we're giving it a try on this project. The glue looks white as we apply it, but it dries perfectly clear. So glue on every segment, spacer in between. Remember again, the segments are the dark pieces here, and the spacers are the light pieces. Other rings, maybe the other way around. There's all 12 segments and 12 spacers, 24 pieces. And we'll just clamp this now nice and tight, but first of all, loosely. And I'm going to go in and make sure every piece is pushed snugly against the edge of the band clamp and flat to the glue-up surface. Check each one individually, make sure it's in place. And as soon as I'm satisfied, I'll go back to my power drill and tighten the clamp for its final position while the glue dries. Okay, there's the ring. Done. After some time the glue's dried, we'll take the clamp off, but the side on the back is not perfect and it's not suitable for gluing yet. So what I'm going to do is get that surface flat. I'm just using a standard 12-inch disc sander, and I'm going to just rub it against the face, rotate it a little bit, rub it, rotate it, rub it, rotate it until I have that back side perfectly smooth. And I'll check that simply by running my finger over the surface and feeling whether or not there's any spots that are not perfectly aligned. A few rubs, and we know we've got it nice and flat, and it's ready to be mounted in the project. So off to do that. Here's an assembly going on. We've added a few rings already, and now time to add the one we just saw assembled. So what I need to do first is to be sure that the assembly top is also dead flat. So a few passes with the bowl gouge to clean up any surface there. As soon as I'm certain that that is as flat as I can get it with a tool, I'll check it with a square. Fingers first. Square will let me know whether I have the edge pretty near flat. If it is, onto the thing I always end up with, which is a sanding stick. Sanding stick assures that this is perfectly flat, and sometimes it's only a few strokes, but the idea is to have this joint between one layer and the next as perfect as I can get it. So a few strokes. The unit we're assembling to is ready to go, and the ring that we just flattened, it's time to glue it on. So let's go on to that. I want to make sure that as I mount these pieces that the rotation between one and the other is the amount I planned for. So I'm using my calipers to mark a spot. And when I put the next ring on, the end of the spacer, in this case the light colored wood, will line up with that pencil mark that's on there. So glue's been applied. I'm just using a small cone to push these pieces into place. And I wiggle a little bit to be sure that the glue is well spread and that we're lined up with the pencil mark. Done. Well, there's a traditional ring, and this is the one that goes on the very top. So it has no spacers. It's simply all, in this case, canary wood. Clamp it up, and we finished building the bottom up to a center point. Now we're going to start building the top down. So let's take that bottom piece off. It's ready to go, almost. And we'll start off with a glue block. Now we're going to have to build all over again. So let's flatten the glue block. This is left over from another project. Looks like there's a little bit of purple heart left on there from some former assembly. So flatten the glue block best we can with our gouge. Again, checking it with the square. And if it looks good, off to the proverbial sanding stick to clean that surface up to the best possible. Now we have a surface ready to start building the top of the vessel downward. There's the ring that's going to go on. And that cone we've tested will work to hold that in place, even though there's not much hole in the center. So a little glue on the top ring, mounted onto the glue block. A little bit of a wiggle to make sure the glue is well spread, and done. Well, the top builds down like the bottom builds up. So here's 2 or 3 rows in the top coming on down. We've got, looks like this is the 3rd row, and I'm just simply flattening it like I've done every other round, sanding it like we've done every other round. See the hose for my dust collection right below the tool rest there. And with that done, we're ready to go and add the next level here. We build hollow vessels in 2 stages, top half, bottom half. This way we can look at hollowing them out much easier. Each will look like a bowl when we're in the process of hollowing it. So here goes the ring. As you notice, the spacers now are the wenge, and the tulip wood is the segment. On the bottom, it was the other way around. You got to a point in the center when they're roughly the same shape and size, and we then changed from segment on one to segments cut on the other. So now we're going to put the two pieces together and complete the outside shape. I've added a device to my one-way live center system that will allow me to screw the top section of this vessel onto the tailstock with perfect alignment. Once we get the thread started on it, there are several different thread sizes that are fastened to the one-way live centers that will give you capability for whatever your lathe may be. So that's the top half. Here's the bottom half going onto the headstock. And what I'm going to do is clamp these two halves together, and this will allow me then to line them up in the order where they're going to be eventually glued, and then to shape the exterior of the vessel first. It's my technique. Good and solid, locked to rest in place. And with my bowl gouge, I'm going to begin to roughly shape the exterior. First of all, just knocking off the corners of each of these rings and beginning to pull them into the rough shape. The top of the vessel has a small curve in it, and so we're trying to pull that curve in, that reverse curve, right near the neck of the vessel. We'll try to get the exterior as perfect as we can before we do the inside. So rough cutting first. This happens to be on the neck end, and now on the tailstock end, or the base version of the vessel. Actually on the headstock is what I should have said. We're just knocking the corners off, as you can see right now. And our next cut will come in maybe a little tighter. I don't want to take the base all the way down to final dimension because I'm going to need the mass there to support the project while I'm working inside. So I'm going to leave the base of this vessel a little oversized at this point. But slowly you can see we're beginning to pull the curve in, create the shapes we want. Starts tightening up a little bit more towards the bottom because it curves in a great deal. I'm still going to be cautious about taking it in too far. And after a lot of work, we finally got the exterior shape just about perfect. And I've gone to a shear scraping now, which takes off much less material. Gives me a much smoother finish surface on the exterior. I can stop and check it every now and then to be sure that there's no little tiny flats that still haven't been taken care of. And when I find one like this one, I can then go back a little bit more shear scrape right along that point until we've made sure that it's totally round. Shear scraping is a fine technique to reduce the amount of sanding necessary. But ultimately, we come down to a point that we do have to do the sanding. So I'm starting off here with a little 120 grit sandpaper, just simply to smooth out. Well, actually, I'm starting with 180, it looks like. Just to smooth out the exterior and get it as close to perfection as we can. And once that's done, we're ready to go and do the interior. So I'm going to remove the headstock, the head portion of this vessel, which is really on the tailstock. This gives me access to the piece that's ready to be turned. So this is the base of the vessel, and I decided to use a series of scrapers to take off the interior. This is a handmade, homemade, standard negative rake scraper. In other words, very slight curve on the face of it. And I'm making some really light cuts here just to get these interior corners cleaned up. I am going to negative rake scrapers that are much more severe in their angles, and you can see the cuts going on inside here. I just wanted you to be able to see how it looks as we begin to clean it up towards the very end. I want that inside to be smooth and perfect. I also want the inside edge wall to be parallel with the exterior wall as best I possibly can. Once I've achieved that, little interior sanding, get it cleaned up inside. And that piece is just about ready to go. So we're going to take it off. We're going to place that with the other portion, that which will be the top of the vessel, which, as you can see, is mostly canary wood with just a little bit of Wenge spacers in there. So we have to do the same kind of cutting again. And here we go with a typical round nose scraper, knocking the corners off as we go down inside. I'm working a lot on the first 2 or 3 rows, just simply to get them perfect, as close as I can, before going down and tackling it deeper. And because of the way the tool rest is set, you can see that the scraper is hanging over the tool rest enough that it's causing me to not be stable in holding it. It's pulling my hand up because it's hanging over the tool rest so far. So I'll change to a little heavier tool, change my tool rest position a little bit here, and see if I can start getting cleaner cuts. My hand is resting on the outside of the vessel, my thumb on top of the scraper to help control and drive it. This cuts much better and much easier than the Wenge on the bottom. Tulip wood is very nice to cut. Smells good, cuts easily. And we're shaping down in towards where that white portion is in the bottom. That's the opening, and that's the bottom of the glue block to which the whole vessel is attached. You can see how my hand position works on these smaller vessels. I have to be very cautious to not let my hand touch that outside edge because it can be very sharp and can cut. I don't want to round it over because it's going to be part of the joint between the top and bottom eventually, and that would be even more that has to be cleaned up if I did that. Scrapers cut less aggressively on the pull than they do on the push, and so some of my final cuts on the inside of this thing are from the top where the glue block is to the center. I am checking the wall thickness of the base to be sure that the top will have the same thickness. So when the joint is connected, the inside edges will also match up as well as the outside. If they don't, I'll have to go in through the opening and fix that, and that's not something I prefer to do. Here I'm doing my final cuts on the inside of the top with a commercial scraper. And I think we have a cut that we're going to be pretty happy with. It'll get sanded inside. And now the trick is to join the two halves together and complete the vessel itself. So back into the original position here, the headstock is going to be for the base of the vessel, and the tailstock where I'm screwing this on is for the top of the vessel. So we mount the two pieces. I'm going to check the alignment here just by bringing the tailstock up and being sure that my rotational positions are identified so I know where to glue is going to hold the two pieces together. And once I'm satisfied that I know where that joint is going to be, then I'm going to take the piece out of the tailstock, put it into where my tool rest post normally goes, and add a little bit of the glue and join the two halves together. Small bead of glue. If there's any seepage on the inside, that'll have to get cleaned up through the opening, a little scraping. If there's any on the outside, I will cut it away in the final cleanup. I will not try to wipe that glue away. The glue will get down into some pores and will cause the finish that goes on to be a little spotty in those points. Line them up, square it up, check my rotation, lock it down, and wait for the glue to dry. So after the glue is dried, there may be a little cleanup on the outside surface. May need a touch of sanding again. But ultimately, after that's done, it's time to part off at the neck of the vessel. So I'm using a thin parting tool, specifically one I've made myself, that takes away very little wood. But I still do overlapping cuts. One cut goes in, the next cut goes over about a half of the tool width, so that I never have an opportunity for the tool to get bound into the joint and jerked out of my hand. And after a few cuts, we eventually part off the glue block. So now that that's free, we have to clean up that place where the part was just made. And so a few cuts here with my bowl gouge again, one to flatten it, and then to be sure that the diameter of the opening is what I want. Right now I'm just flattening across that area, slightly incaving it into the inside just a slight bit, cleaning up the edge. Now that I've got all that done, the work inside is finished, the neck has been finished, it's time to finally reduce the diameter on the base and get it down to the proper dimensions and the proper look. So I'm starting to take away a little bit of that bottom row or two of wingay and into the ebony foot that I've added. First cuts here are being done with the bowl gouge. I'm allowing the tool to take its time to cut. The ebony is an end grain piece, so I'm hitting side grain, end grain, side grain, end grain. And I want to be careful that I do not chip or catch on any of that end grain as it comes around. So I'm slowly removing the unnecessary exterior wood. And now I've decided where the base is actually going to be in a few parting cuts here. Not deep, but just enough to mark off where the end of the vessel is going to be. It helps my eye see the finish bottom where it's going to be. And you can see that I'm just making a few light cuts here into the ebony. Now I'm back with a shallow fluted gouge to take the last few light cuts to bring that ebony down to the proper curvature. Little light pressure against the wood. Wait for the wood to come around and cut itself. Once that's been shaped properly, a little sanding here to finish up that area also. So we've got it done. Now it's time to see it really begin to pop. So I've turned the speed way down, and I'm going to apply a little of my Minwax wipe-on poly, the clear coat. And the first coat goes on fairly heavy because a lot of it will soak into the wood grain, acting as a sanding sealer, or a sealer in general. And as it dries, I'll go back and go over it again. So I'm putting on a fairly heavy coat. The inside also has to be sealed. Many times the inside I will use the wipe-on poly also. In this case I did. Other times I will just use the interior sealer as either a cellulose sanding sealer or a shellac. So this is coat number one. And we're just layering it on fairly heavy. Well, after that dries, it goes back onto the lathe again. And I'm going to take my 120 grit, 180 grit, 220 grit sandpaper and sand this back down to the surface again. What I'm doing is allowing the finish to fill into the pores of the wood and establish a flat base. So we need to do more sanding. Sometimes we don't want to, but we do. I'm finishing up here with a piece of 4/0 steel wool simply to give a really nice surface finish. I'm going to do this about 5 times. It depends on the wood. If it's very porous, I may do more coats. If it's very dense wood, I might even do less coats. But typically 5 to 8 coats in this process. Apply a coat, sand, apply a coat, sand needs to be done. In the winter here in Northern California, sometimes that's a couple of days between coats due to the moisture content in the air causing the finish to dry much more slowly. So here's the final coat going on, and we'll spread that around. We're going to allow that to dry. And now the separation needs to occur. I need to take this project off of the glue block and free it. Here we're back to the live center system again. And I'm now going to move the vessel complete, faceplate and everything, onto the tailstock. This gives it perfect centered and gives me some holding power. And once it's mounted, I'll be able to use it with my vacuum system, which then will push it into the vacuum chuck very well centered. So here's my vacuum chuck going on. This is a custom made one I made that's right for this size of a project. And when I push this in with my tailstock and lock that down, I know that I am dead center. So now it's a matter of parting the vessel free from the faceplate. Back to one of my thin parting tools and overlapping cuts, and I take quite a bit of time to do this. I do not want to push across this. I want to simply hold the tool, allow the wood to come around and cut itself. I don't want to displace the project against the vacuum chuck. Well, eventually we get it parted off. So now we can remove the whole tailstock assembly out of the way. And there's still a little cleanup on the bottom to be done. You can see the marks left by the parting tool, and I want to cut all that away with a shallow fluted gouge and very light cuts. If I press across, I can easily dislodge the vessel from the vacuum chuck. So I'm not applying any pressure. I'm just trying to take those spots off. And as soon as I have that down to a base, I'm going to change from this kind of a cut to a cut where I'm pressing toward the vacuum chuck. In other words, a shear scrape, just to finish cleaning up that bottom. And now a little sanding. And on all my projects, I do a little decorative mark on the base. And so it's time for me to put my 3 lines on. So diamond point tool is line number 1, number 2, number 3. And the project is completed. So we'll take it off of the vacuum chuck simply by reducing the vacuum, turning off the pump, and the piece just falls free. And there it is, completed, done, sanded. I haven't buffed it out yet, and that's the last step I will do. And it comes out looking sort of like this when we get done. So there's all the steps I go through to build a project which is a simple segmented vessel, but with a number of varying thickness spacers.